Hello, good morning. Okay, welcome back to our malware analysis. Our
Good
class
morning.
for
Good morning.
good morning. Okay, so just let you know I just posted a new assignment. So if you try to follow the lab on Tuesday, and just like I let you to install the easy and then using the UPEX. So mainly you just like follow the previous all the steps, and just you need to do is like compare. So you can start with the like unpack with the unpacked one, and then compare with the packed one, and then after you use the UPX to unpack the file, then you can check it one more time and just have some like discussion and tell me, okay, if you have some difficulty or like in the process, then also you can put it down on the your report. Okay, so mainly you just need to make the screenshot. Okay, so show me and tell me the result. Okay, so that will be our static analysis. And for today, we'll move on to talk about the dynamic, slightly more like dynamic. So when we do the malware analysis on the VM, then we need to think about, okay, what are those like antivirus programs having like common with the human resource, like maybe department like this? How can we check? So mainly, okay, if you let's say the HR departments maybe open all the attachment in order to run them, and then if there's some like program, they will execute all the payloads. So in order to NSI them, um, when we try to look at those like maybe some attack or like surface of program or something just function, so they require some like safe environment. So for like through the VMs or like the sandbox. So pretty idea, similar idea, and just a VM virtual machine easy to control. And sandbox is we create for testing, and then we can run it. You can see here is one of the like some case, and because the malware execution without a sandbox, then if we have some like AV, then it's worse than not having it. So one of them is telling about the Windows Defender bugs. So they just like so grabbing and this POC exposure have to be encrypted. So it's kind of like happening like this. So after they schedule a scan, so after that, so it just like is what's the result of the vulnerability of the you see the X64, that means the 32-bit emulator. So they're not being protected by the security sandbox. So they're being just remotely accessed to the attacker by design. You see the idea of the sandbox, because when we try to scan, I think maybe you have slightly idea, or like before when we discuss about the detecting the virus. We use the virus total, or like all those like when we detect and look at it. How are those like antivirus software detect? Is like by the bit pattern or like by certain header, right? So you should have some idea of it. So if we don't, right here is a security issue, is that they are not like protect using a sandbox. That means they try to create a virtual kind of similar idea like virtual environment. To imagine that sandbox like more like isolated environment for testing. So they will just let the attacker. So they really, because they are not protected by the sandbox, then that means like I try to execute the file, testing it, and in the first I just open the maybe some backdoor. Okay, letting the gateway like for the attacker to remotely access. So it's the issue. And as like follow up, sometimes when they try to, especially maybe in the beginning, or like try to improve their Windows Defender. So you see after Windows introduced their Defender, then maybe they have lots of risk. So when they just like release it with our sandbox. So it's like this. And we may thing like because the sandboxing maybe is one of the most effective security doing techniques, then why the Microsoft like the sandbox will have like some other like high value attack surface. So just like that, just like the code and Microsoft Edge, but leave the Windows Defender like undefended. So always there's a question. So and then later it comes out. So it just has become the first antivirus to like run inside a sandbox. So it comes out. And you see the Windows Defender with the sandbox, they will support rolling out to the Windows Insider, and some Windows 10 user can enable it right now. So it's pretty long time ago. It's 2018, but when it's like getting better. And the approach for like doing the like we provide the sandboxing. So we mainly have three different types. So one is the emulation based, and then the hooking based, and then the hypervisor based. So we'll be these three. Okay. So when we look at the first one, the emulation based, so we will try to make the entire machine. So emulate on the an instruction level base. Okay. So the QEMU, so it's one of the full emulation mode. It's safe, but the downside is like it's really slow. Okay, so maybe we are trying to have like the Linux ARM on the Linux x86 Okay, so you will see right here the structure. So below we have the hardware like CPU, RAM, devices, right? And then on top we have our OS, also OS. If we have the create a sandbox, that means like okay, we have a target, maybe create two systems, and then that means we have to have an emulator 1, 2, and we will try to monitor those like sandbox 1, 2 right here. So we'll keep checking. Okay, that's how this idea is working, and you may be using the you name you check the arm and then to look at it, and also you can like check the files listing. So this one is the executable and then there was the version. So here the example to check it, and then the next one is the hooking base, and it will run the malware directly, but the hook system and library calls to log activity. Okay, so here slightly not on the same. So it's kind of simpler and lower overhead than the emulation approach. And what's the issue? So when we running the same privilege level as a sandbox, and also it can detect it or like tampering with it. So kind of the lack of security. If you look at the graph right here, so hardware compared with the hardware before, like hardware we have the CPU, and then on top of the CPU, so we will create different like limiter like 1, 2, and then create like 2 sandbox, right? So far so on, and then we can create more. But for this one, we will have the sandbox monitor. So this one is sandbox visible in the system. And then we have the OS kernel. Okay, OS kernel, that means will be like the under Windows, and then we have the driver. So we'll driver hooks, and then maybe some API, and then system call. So you remember the system call. So all these are visible, and then under this maybe we have some like device driver. So all these will be the under the kernel, and then we have maybe some other running process running on it. And when we try to monitor, then we have the malware process right here. Okay, and so it's just like code. We just like run the malware directly, but just the whole system and library call. So you see that maybe the API hooks right here, system call, some driver hook. So right here, so we can able to log the activity. So what they are doing. Okay. Then this is the hooking base. So we will like often done like with the disposable like VM or the VirtualBox or the VMware. So we doing. So we record and we play the execution and perform the snapshot, and then rollback, control the networking easily. So when we create the machine and then with the OS, right, we have different application. Then we own the virtual machine, and virtual machine will execute some virtual like application. That's kind of what we are doing right now. And like for mail and access, when we of course like because in the lab, because we need to protect system, but in really daily operation, how you actually use your computer, and most of the time, okay, so it happens that okay, we have the application, but of course for this NSS, then it's better to create like more safety, create a virtual machine and then execute those virtual application. So it may be a good habit. As well as share, like before, I always use my Windows to install. Like I love to try different type of application program, and then lots of them they contain virus or or some of them they try to modify your registry files. Okay, so maybe if you want to test, it's a good idea just like create a VM and then you just like test the new application. If it's safe, then you can install on your own. So maybe it's better. And then the hypervisor base, that means we put the monitor in the like hypervisor running the VM, and it includes like the sandbox monitor, like it runs like below the malware. It's really fast and then safe, and then they also have a resistance to like detection and timing by the malware. The trade-offs like between the visibilities and speed. Okay, so one's got a VM rate, so it's more like a closed source. The structure right here. So we have the hardware, CPU, RAM, so the same, and then we have the host OS. And we have called that like capture the hypervisor, and then we try to create the like sandbox monitor, and then we try to like virtualize the target like system 1, 2, like this. So right here you can see it's like if the virtual target like create for the full monitor system, then we have the a modified case like system will be right here, and for ourselves like will be hardware we use by the yes. Okay, so compare the free structure. So like for different types. So because for running on a VM, but it will be pretty similar to the emulation base, and for the hardware host OS, and then we try to like create individual the emulator, and then try to test the system. So very similar, but this one is that you don't have a visibility because we just like come with only one the sample monitor and in behind. So all the virtualized target system will be behind. So it's like the not the same. And then of course we do have something when we want to check and when we try to install on our own desktop, then next question is can we always like do we have any service application like working on the cloud or like the sandbox that we don't have to host it, or we like test by other company like service provider. So this one maybe called the hybrid analysis. So surveillance on demand, so like detonation or analysis. Because you can save on the like infrastructure cost, also the management cost, and also it's more higher security. Because we don't have to for infrastructure and management, because we don't have to create like maybe some virtual machine and then manage it, or like create even the virtual machine sandbox we need to install it, set it up, or like maybe the some like make the entire machine in the on the infrastructure level. And right here on the car, maybe the coverage they will using the VM after you upload the file. So if you drop the files and then they have the VM, and then they'll execute and then doing the detection. As well as here one of the VM rate. So if you remember, VM rate is one of the example right here. So after we upload it, so we don't really need to. And also We only care about the speed. Is okay, one safe, of course, and then the speed is getting fast, like being, and it's like good to provide like serving the sandbox in the car, and then and then like anyone. So also this like the time lab execution or replay denotation, detonation right here, and then we'll count the source of sample. So it's one sample. Okay. And let me open it. Let's say right here. So you look at this the graph right here is pretty like always IE and then some analysis, and it gives some like returns speed like IE spectrum like this, and it will giving you some like information. So I think if you have the link, so you can try to click on it and then open and take a look. And this I kind of like is running on it, so it will some like showing you some what are the exposure some on the like IE executing. So this one is the web-based one, and then injecting all these things. Okay, and then okay. And that's one more case is telling like in 2015. So some like we call that like sandbox like Fire Eyes applicants. So they can be used to attack the network. So it's on. So they will maybe have some like static analysis of the Java the bytecode code and through the Java decompiler. Okay. And so it didn't run on the VM. But so because you didn't realize that the compiler execute the bytecode and as well, so it just like instant remote the code execution. So it corrects the both to like perform the server side request, the forgery attack. And when the malware in the sandbox scans the internal IP address and then filters the data. That's why in the malware, we will install the fair VM. Sometimes you feel the network connection. But in the later in the lab, I will let you to really execute. So be careful. So after you install everything and a working environment, so remember to take a snapshot and then use that snapshot to execute. Okay, because of course it will crash your system, and just be careful. And this one time when I mentioned about using your VM right here, so if running on the VM and then I told you go to the network and then the one I didn't open it, so you can go to the network right here and load it. Okay. So we have a network adapter and then try to do the host only. So it will be like isolated, so it can protect your VM. So it make this VM isolate, and then it won't like help you able to access to your desktop. So it will provide high security. So just remember. So later, if we because mainly in our this like two labs or exercise we are doing, so mainly just doing scanning. We are not really opening. So far still okay. And but if you want to prevent like something the virus looking like scan some internal IP and then like scan hosting website, then try to prevent it. Sometimes you see maybe some a single email, so maybe give a hacker full access to your network. So when we open the net email too. Then we will move on about like evaluating the sandbox. So when the malware like quitting immediately or like executing like innocent code. So if it like detects like some artifact of the sandbox or like the time anomalous, so most like 50, so almost like half of the malware they're doing. And Then we would detect if a system they are not being used, so just like the OS is fresh, so we never use it, or we try to like detect if a system it doesn't belong to a specific target. So maybe they will try to check the username, the IP address, the domain, the registration file, so startnext, the frame, so all this. Because the malware they often like try to do a multi-stage, so they will choose when the adversary like choose if the subsequent stage they ascend. So all this they once we execute certain application files or like email whatever execute, then maybe they're checking okay, and they will delay the execution. And that one here's the term to the time bounds. So it to bypass the check, and others say they must hook with other method for like sleeping on the system or counter. So if you remember, we have some when you write a program, that's how it looks like. So when we writing a program, we can like some like you can like simulating by like writing a sleep function, like sleep how long, and then if we are executing program, we are not executing within certain time. So for the time bound, we can set the time base. Maybe after the user install like for certain of time, then we begin now execution. And then maybe we try to like spamming some like library and system call or interleaving malicious like snippet. So we are like legitimate use some over a long period of time, especially for some like N1-based machine learning detection approach. Maybe for nowadays, maybe the malware also like getting more powerful, so they will detect system. So right here, so you see they try to detect like 7 stage, like all this. So it's artifact or there's some system, or I'm not sure how many of you tried. For some application, they are not allowed, or like have you tried to use some service like they're not allowed to executing on the VM because then they will try to validate or check the they will do some detection. Okay, checking is this one is on the VM or the sandbox. Okay. And here's a complete pictures like for the full stack automated malware and SS. When we get some different type of the files, and then we pass it to the reputation engine, and then this one here. So we'll do some like static analysis. And for the deeper level, we do is like dynamic analysis. Okay, for the dynamic analysis, then we will pass it. You see right here, maybe we have the sandbox monitor, the hypervisor, one of the model we're using, and then to analyze system in 1, system 2, we do it. And then we will provide the severity score, the VIT, and including the reputation, and then static, and then the dynamic. So all this the overall. And we'll cover this part. The lecture is about the move on about some like basic dynamic analysis, and the basic analysis including kind of ideas that we try to monitor in the execution. So that's a reason why we need to create like we have 3 types like base to doing like dynamic. So once like on the like VM or sandbox, we try to examine the execution. And if you just like slightly recall what we do in the lab, because we try to just like checking, you see he had the doctext data, all those files that they compare it. But for that one, maybe not able. Okay, because especially most of the applications are pattern, and we don't know, right? Then how can we check? So most of the time we do a dynamic. So for the deeper version right here, do the dynamic analysis. So we will execution will check the binaries. So when we check the executed, so directly launch or some like debugger, so we check. And also the DLLs, so the library And then those like maybe execute with the web process like run DLL32 exe on the Windows. I think pretty of you maybe see this one, the run DLL32. And what kind of behaviors like when we like monitor those in execution and behavior, including the like process activity, and also process activity, that means that we're checking real time, so what is accessing, and then the file system activity. So is it like try to access to our storage, like secondary storage, or like access to certain folders? Okay. And sometimes they're not required to access certain directory, but it try to like reach to certain directory. And then the registry activity. So you know this one, they always the malware they will edit the registry, and it's really hard to decode. Or like sometimes you think you already delete the file or like delete it, but actually it already like added to the registry in the system. Then it's really hard to do. And then sometimes networking activity. So this one is pretty common. So it just make you like occupy all your bandwidth. For the system, we have some like different tools in our malware analysis. Will later you will see actually sometimes we say more like in practical, maybe we have long time ago we do have some application and come out new, and maybe some like here will be the cheat sheet like including like basically for our do the dynamic, we're looking for the process or the directory for the user or the logs, then we can do it. And then hasting maybe is echo. And then for the process includes some like we're using top we're showing all those like large amount CPU RAM. And then some like process tree, pretty common, especially we feeling okay, your system, this one is on the Linux or like in Windows, we can do it too. It's like when you feel okay, why your computer getting slow, or you feel like why it's like taking too much time to doing execution and application, then you want to see okay what the resources that occupied. We can use like top to see okay, always you will see there's some surface application running taking most of the resources of your CPU or RAM. Then you can looking for okay, where is a directory. So it always the first step we try to looking for some application, and then we do have more. Later if we have some name that I'm asking you to memorize all these like what the type, but you should have like based on this 5. Then you should have an idea like how can we check the directories of the process, and then what's the directories like pretty common temp, and then the var temp. So all this will be like run. We also, if you remember, like we have the some working on the Ubuntu, the Linux system. And for the temp, for the Linux system temp is more like the running the stuff running on the RAM. So when we there's a process like maybe like taking lots of resources, maybe they will also exist in time. Okay. And also looking for some files like immutable files or some directory. So we try to grab some certain files right here, and then maybe some of them maybe the files maybe looking for directory is no user or good name. So it's like high possibilities, and then looking for some file types, especially for some like malware application, they don't have specific like regular file type. Okay, most of the time we have like text file or maybe some PDF, JPEG, no, but there's something else. Okay, and for the user, maybe we can check all those like SSH. So here's the SSH is like allowed to authorize for the connection, and we'll look at the authorize key. So you may be able to find some like if there's some key that not supposed you never upload it, or not belongs to the user you create, maybe because the malware they try to create a user and then add the SSH key, so allow the attacker to access it. Or maybe we can check the history of the files or link it to it. So this all. And pretty common we try to checking for the log. So looking for the VAR log. So maybe some application, do they have some like zero size logs or some items like audit logs? So all right here. Logs will be um pretty much of time we'll touch on. So look at those logs and then how it helps us to monitor the activities. Sometimes you see the process they create and then what kind of logs. So that's how we try to do like we can use all the function right here, they are all exist in the Linux system, just like is more once we look at it, then how can we like based on the result, then how can we doing the analysis? And for the rest of the slides will give you lots of examples, and I just like go through all this, and later if we have the chance, then I will let you or some exercise, then I would like to show you, let you try. Okay, for the process activity, so we can like use the function like process utilities, so including the PS PS3. So you see a tree we're showing for the as for the let's say the Chrome will be under like in this tree under how many columns they created, and then some helpers right here. So you see the text like you see the process ID, right? Okay, so what the CPU is taking, the memory is the size, so right here, so you can log it. And then top is a pretty a lot we are using, and it will list all the process like ranked by the usage. So when you type the top, then it can show okay what are the process right here. Before I use it to test, because as what I say, because I always like use my own laptop to test with some online application like free to download, then it always happen. And then you see when you check, then this one top is pretty common to use to looking or search okay what are the application surface running it takes. Of course, like if you're using the Windows, also you can use it. Let's say for my Mac, I can go to the something similar to activity monitor, and then you can check, okay, right now where's the process like occupy my CPU, take a lot, and then maybe your memory. If you look at all this, I suppose it should be kind of like pretty normal, like the low and then the usage. Because suppose like I know right now in this moment I just like have running the Zoom, and then maybe I will have some I open a PDF and then some other service. So all this looks like pretty okay, right? Or the memory, so is any application like it takes too large like memory space, then it's okay. But so far you will look at mine, then it looks pretty fine. So I have like 48 GB memory, then I just use like 13 GB is pretty normal. And so you can like define like this. And actually when I open it, then you see what's the highest like process like ranked by the usage. And also we have function is like pause this and then df. And this one will be have a direct access to a process or devices, so including a memory. And right here you see we there's a code app.python like Python to list, so we can list it and then ps do the process or like list the process. So right here all these the process like including, so maybe some mapping files mount and then some stacks, so system call tasks. So we can like able to check it and list put a lot, we'll see use a lot. So we'll see the when we using ls and then showing okay what's the files the access right. I think if you remember cybersecurity or we learned, so it get the 77 and then it belongs to the owner, and then you see pretty similar we are using like for the data. So this one is like open, this one is the group we're using. And cat, we try to list like what the process. And right now here will be the like the headstone, and also like we try to get the process, like which process the maps is the function. If you look at the slides, will be like just like some example, but of course like in the lab time, then I will let you to try. And just keep going, and then we have some, if we want to see some like deleted binaries with the process they still running, so we can use the ls with the passing by the AR, and then pass which process the extract. That means the start will be like anything, so exercise, so we just get those like deleted. Okay. And here, next for the process, we running like from the temporary files, the device directory, then also we can do it. So we can just try to grab. So you see we pass the priority grab. So it depends on what we actually like. For the executing file, we just get those like deleted. And then for those like for directory process the CWD, so we'll be like we're getting the directory like TMP or like the def. Okay. So you see pretty similar idea. And another one will be the strings. So we will try to list the process environment. Because right now I showing the how the I think I used for the digital forensic. If you see I try to list the MD5 like English using strings. So even for the environment like process with the PID when we pass, so you see some like parameters. If we have a specific process, then we want to check the environment, then we also can like list it now. Okay. So we have the L trace. So we will try to like looking for the those like hook the library calls and dump the argument, and we turn the value. This one is also, if you search like Google online and put it a lot, we will using this function to chase like list those like codes. So you will see maybe some link right here. Okay, in this workflow, we'll like do something input password like this. So here will be the L trace, and then the S3. So S3 will be hook the system calls. Okay, so once for the library, another one is for the system call. And also we can use it to dump the argument and return the value. So for X-ray, and you see, maybe we try to open what the maybe open read write. And this one will be like for some testing program. So we'll see. And when we open it, you see, okay, we have the X-ray looks for the process ID, and or the system call, maybe we try to read something and then write to a certain level, and then write. So this is system call write, and how it looks like. And then we maybe when we set up the like the time bomb. Okay, so all those like maybe we can check the some schedule task. So the count, sometimes we call the count or like count tab or count job or all this, maybe we can use to check. And also yourself too. If you want to set, let's say for some application to run repeatedly regularly, then you can also using the content. So maybe you can like run like every second, okay, or like maybe every week run it once, or like month, and then you can set a time. So when we set up like schedule a task, then it's really, sometimes if you don't look at your some of the maybe some malware application they will set up, so it's really hard to detect. They will wait it for a certain time and then just like execute. So they will detect the system, maybe they will turn on your computer in midnight and then execute. So you maybe have to find it. Okay. And then for the process direction, then we also have a file system activity. Related to the file system activity with the list OF. So it will list all the opening files. So list all the opening file descriptor. So maybe we appoint some like the Python process. maybe the current directory. So you see what the directories and then the interpreter they're using, and then some like libraries standard in, standard out, like this, and then what the pause. So it will be, we can use it and pass a parameter, and then which process. Okay, so after we figure out which process, then we can also this one. And for some sensitive file system location, including the temp, the runtime, like def shm. So if you open the our Linux system, so I mean showing the Linux system. Okay. So maybe the temp location or like the runtime, and also the VM. So I would like to. Okay. So right here, and because sometimes if you see we have the cache file, and sometimes we need to like check the log, because sometimes they will let me check the log file. So right here are the log files. So in case we are in, so, and also sometimes maybe the audit log SS, and I can also show you when we executing the top. Okay, so right here under the root, so all the application. So far right here, because this Linux system I'm using is for testing. So far I didn't install any malware application, so it should be looks like pretty okay. And then the process ID. But later I will try to give you something to work on this, like try all this and looking for your data. Okay. And then maybe we maybe have some like sensitive, like persistent, like configuration, location, etc. I'll see local. Okay. But sometimes for this, like they are the look at it, it's the hidden file, so it may be not able to access or not exist. The initially it will be the some like application we're going to execute, but we need to sometimes like we have to edit it or like cat it directly, maybe not able to find it on the list. And then list all the file type in the current directory, so you can use files and then list and from the parent. Okay, so file like this, what the file type like this, so we can check. So if you find some file type they're weird, then it's a good hint. Okay. So of course we have maybe some like some executables anywhere 10 like this. Or if we want to find some like hidden directory as well, say because we have something hidden, and also we can use the file and then pass the parameter. What's the name? So this one will be the file type like dot abstract, that means start, that means anything. There can be some like hidden file. Okay. And if we were looking for some file that modified or created within last day, so you have the time in time -1, so it will be last day. So it's possible. So another one we can use is profile. And the next will be the network activity. Related to the network activity, all of it is like the LSOF, the list. We can use it for find all the TCP socket. So in the listen stage and some process they're doing, so they can like list it. So we try to list all the TCP, and then what's the listen stage, and then it will list all this. Okay. Or next step, so the network statistics. So we can this one in maybe when you start maybe before in the cybersecurity, or if you study networking, then you should see this like pretty often. So the next step, so we're looking for it, and we see all the socket. So what they're listening and establish the connection along with the process. So belongs to. So like maybe what's the protocol they're using, which maybe address they try to access, and then we mainly focus on so the listen, and then which process, and then what's the program. Okay. And if we want to see the routing table, so also including the next step, and then for the routing dash R, so we see, okay, maybe for what the gateways they're going to, and then what's the mask, the mask, and then which one is the default all these like routings. And this how we are doing the analysis related to networking and then netiquette. So we will try to read and write data over the socket, so we can like echo for a certain right here you see we are trying to this one echo to passing HTTP is one of the connection. So it's like okay 200, okay, and then with getting the date, and then you see right here create a new line tab and then get the hello with the actual. So all this will be showing the value. And then when we get it from local, this one is the actually running as a kind of local host to return the value. So right here, so you see the agent was the host, and then it said came upside that was the HTTP protocol 1.1. So it's how we can check it. And then we have the DNS mask, and it's DNS MASQ. So it will kind of like lightweight and configure both DNS and DHCP server. And sometimes we can check the DNS, they will max the name. So let's say the Google, and then change it to the IP address. So because we don't want the network to connect to the original site, but you just have your own. So for some example, if we want to like doing the DNS masking, this one is like running on the machine, and then we just carry what is the masking configuration. So if you want to like add some domain, you want to force some IP, then you can say right here, okay, address, and then which one, and then giving an IP address, and there was some like core address like practice, and then all these like 127.0.01, so they will be the local host. And then also you can set a resolver on the client machine, so we can point to so where the DNS and SQL is running, so we can check it the resolve, so it will show it. And this is how we setting for the like for our own DNS server level testing. And another one is like the INET SIM, so it's immediate the common internet service. So we can use that in the some conjunction with the DNS mask skills to redirect the connection to immediate network service. Okay, maybe including the DNS53, HTTP 80, like HTTPS 443. So all these like common port using like FTP 21. And when we want to check the network traffic, then we can use one called TCP dump. It's kind of similar idea, so but this one is like showing for the network, so all the network traffic when we pass in the TCP dump with like parameter -i, and then EMP this one, this which one define, and then we checking which port, like maybe a TCP and then the port HTTP. So when we listen on this, then maybe checking, okay, so they have the link type, okay, which one they connect to the Ethernet, and then what the size connected, and then maybe some like IP they connect to certain Comcast, okay, maybe some school, okay, HTTP. So all this will be displayed, okay. And then move on to the one pretty common, I think use a lot is the Wireshark. So Wireshark will help us to capture all the package. So kind of like similar to the TCP dump, and it just like come with the UI. So you see, so it shows all the maybe some like TCP, and right here to put all the payload. So I believe all of you are pretty familiar with this one, the Wireshark. Okay, if you study internet, or you may use it to monitor your network. Okay, and here we give you some example with the tool for the dynamic analysis, like we're working on the Windows system. Okay, the program will be like help us to checking the process file registry monitoring to check the execution behavior. Using all these are Linux, we can use the ltrace, trace if you remember, and we can use some application helpers, so we can check and then it just execute and looking for some this one malware creating their file. Right here, the certain operation, so will be the process right here. So they were looking for some directory. Okay, and then for this one, it will give a function to like for filtering the vector set value with event. So you see right here, they will try to checking the they were giving some value like mm32ex and then included. So this one will be the value, and then it will like revert it and has itself in the one of persistent. So later it will like running it by itself. So have a budget set and set the value. So you see. And also we have the like called a process explorer. So it can have a process tree list. So similar to PS3. So we can determine if some like malicious documents they are logging new process. So we can looking right here and then change our process 32, some like SVC, also like exe. This one will be really depends on how familiar you on the system or something you running. Personally, this one it takes like some experience, and then have you ever like pay attention to even I can use the activity monitor and checking if there's some activity they are look like abnormal, okay, or they are irregular or just new, okay. Of course some of them you maybe have no idea or some application, so that's why we need to compare and then check which one like takes most of the CPU processing power, or suppose they shouldn't run in certain time. So that's how we need to do, and then we try to examine all the resources composer they use. So all those like properties. So if you see this a pretty old Windows system. So we try to verify the running process against this executable image. So right here looking for the image, and then let's see if they execute present path is exe, and then what's the command line local surface. So they will on the directory system 32. So those like malware maybe like performs the process holding. So we can verify it. So once they click on the verify, and then we can examine some strings in the process versus the strings on this binary for particular versus. So looking for some parameter, and then what's the versus version info, and they have the resource, so they reflect some change in the registry. So the registry is the OS data structure of configuration, as well, you know. And then they will compare the first shot and second shot. And of course, like in our lab, we'll do something similar. And we can view the malware is giving itself the precedent on the system. That's why we say the registry. So they always try to edit it, that we need to check. Appended DNS. So it also try to capture the DNS request and modify the replies similar to DNS masking. So this one is more like something more comprehensive. But because it's just a lecture, just like we just go through quickly like different type, and then what kind of tool or application we can use. But in the lab, I will try to use others like for participate. And then the netcat, same again. So for the Windows system, so also we can read the data and like read and write the data over the socket. So it's kind of similar. So like naked and NC and list P which port IT. So just like pretend you're going to which um maybe Google, but spend the reverse shell to give it to the receipt or something like this. And then they will have more like the as what you see before, like on the Linux, but also on the Windows, we have the Wireshark to capture the package, like the TCP dump, and then the unSIM. So all this. So right here, we see like in action actually in the virtual network, and then we have the virtual VM machine. It owns the IP address and then DNS server at the local host, right? Maybe we'll try to have some like DNS requests, maybe some HTTPS. So we say, so when we have the Linux virtual machine and a SIM, so this one it will have an IP address, it keeps sending like pretending. So the HTTP 80. And if we remember, we try to set up the DNS like 53 that append the DNS redirect, and then we redirect to this like virtual machine location. So that's how this application, like when we showing the application do it, then we can like capture it as a, and that's how it looks like. Because pretty old, long time ago, still possible, but maybe not able to capture the process. Right here, by new text and show some single execution. It looks like, but because now the malware they change a lot. Idea mechanism like how it works is similar, but of course we have some like new application, and then they try to like search as well. We say maybe like for the search base when the malware it detects on a VM machine or like some network setting that maybe they're not going to execute, then you're not able to find the malware. And just like go back to give you more some example when we try to contact with the server over the port 443, so HTTPS, but they didn't speak the SSL. So right here, so they are residing on the SSL, so they're not talking in SSL format. So it causes so they maybe have some custom protocol, so which used by the Wireshark. And give you more example, maybe or some like multi-platform analysis like OSQ 2014 video, but it's like developed by the Facebook. So help us, but of course we have more, and then maybe we can use the SQL queries to obtain some process and file systems and networking and some other OS information across all the machine in the enterprise. This FACO standards, and then they give you some example. So this one in the using the SQL query, so to select like what's the name PID from the process. Okay, that's how this one I'm using. And also like when we checking OS query, then we can select, okay, what's the PID? So PID was the name, so from the process. So this one is pretty similar. It looks like our database. So it's one of the application. So if I just quickly go through all the lecture part, so we just like slightly recap. So we introduced like mentioned some tool for dynamic analysis, like for the Linux system, Windows system. Because when we learn the mail analysis, and because it's possible like in different OS. So when we working on the Windows or Linux, even like Mac, so they're pretty common. But because Mac is more like code system, so we barely like discuss in the lecture. But most of the time we try to monitor, we always try to create a VM and examine their like binary and DLL, the load library. And we're giving some examples like how can we examine those activities, including the process, file system, history, and the network. So we have different application software to help us, and just go here the stack and then the forward, including the reputation, static, NS, and dynamic. So in our previous lab, we just like try to see some work on some static analysis, and later for the lab I will give you some exercise like to doing some dynamic analysis. to check the activities. And also your VM, we try to really execute some malware application. So being like head crash. Okay. So well, that's it for today's class. And I see some students right here. So do you have any question about the lab, and do you like confused about the assignment? If you don't have any question, or if you need some extra time to work on your the mail analysis, let me go see. Suppose if you are able to follow all the steps, and right now I'm keep uploading, make it to public the video. Okay, so when you download the VPX, I for those if you don't have any question, then you feel free to leave. And if you have the problem, okay, can you tell me what happened, or like when you download the UPX? Let me open my VM. Bill, I remember you mentioned about the network. So if you don't have an issue to access, then it would be pretty straightforward. Like if you don't use the link I gave you, so it's like the UPX download kit, and then you go to download the I think let me see. AT. Okay, so if you the reason because you didn't put it to the system32. Okay, so if I want to execute UPX like this, I will still get the same error. The reason why, because we didn't put it to the system32. That means that we don't the system cannot recognize. Okay, this one. So you have to either you copy this UPX to your system32 Windows. If you one method is that you can copy the UPX, go to C, and then Windows, and then system32 right here. System32. System32. Okay. So either you copy the UPX to system32, then you can use it directly. If you let's say if I don't want to, then you can just like change your directory. Okay, you need to change your folder directory. CD. Okay, I change to here. Then I can use UPX. And UPX we need to pass. Okay, so I need to pass the parameter. So UPX, let me right here execute. Okay, so I can execute the UPX and the output of the file. So you can execute in this way. So I'm not sure did you like start on this part? So right now you see you are able to execute, but because I don't have it, so I don't have it padded. But right now I can execute. So remember to change your directory. Or if you can like put the absolute directory, that means if you are let's say we open a new one, then you need to put the exactly the new directory right here. So under C, row, and then slash. And then it's exe. Or you can do it in this way. So either way is okay. Or you can copy the file to system 32. So all these files copy to system32, then you can use it. Okay. And then you may try and execute. So I think this only is a possible reason why you couldn't use the UPX. Okay. Yeah. So you can copy to system32 or just execute directly and you can try. Okay. Just let me know if you still have some problem to use the UPX, then let me know. I can extend that deadline for you. Okay. And if you have no other question, then I will finish the sharing like for today. And because right now I have not yet posted the link, but suppose I maybe keep on upload more videos and then I will make the YouTube video. Okay, make it available. Okay. And thank you. Enjoy your day. Bye.